Hello, welcome to the Legend of Data. So it's Monday, and we start the week by learning how to do pandas. So it's like a continuation of the workshop last week that we started talking about pandas, and so let me drive through the slides. I think because this is a new series, I would try to do a little bit of self intro before I dive into the topic. So I'm Chuck. Hello, and I am actually an ex data scientist. But while I was working in data science, I really love open source projects, and it's super bright when my screen is is white in the background. So like, sorry about that. I look like a ghost. It's like growing. Also, I love organizing different conferences and different workshops for people to learn more about Python, and also I'm involved in some of the PyData events. So so yeah, actually like right now what's happening is PyData Amsterdam is this week. So if you haven't get your ticket, there's still like 4 days of events plus the sprint on Saturday. So I think it's still you can still sign up. It's cost you a little bit, but it's also the money is mainly supporting the community, supporting them focus to drive the development of projects, for example, like Pandas, that could let you, it's open source and for you to, use it in your data science project. So yeah, it's a relatively cheap conference because it's online. So I would recommend you check it out. So it's part of the Amsterdam. So today we're going to talk about pandas again. So I think I've covered this last week, but I'll just quickly go through that in case you missed the tutorial last week. So Panda is a very powerful tool for data manipulation. So I would say it's kind of like there's many ways of using it. It's not just for data scientists, but also if you have a data that is in a tabular format that you want to join them together, or just do some aggregation. That's actually like quite helpful, or even like sorting it. So yeah, like Pandas is super popular. It's a little bit heavy, I would say, because it's kind of like a multi-purpose tool. But I mean, this is very useful as well. It's relatively fast because it's using NumPy at the back. So NumPy, I think, well, maybe we could talk about that more in the future. But NumPy is a tool that lets you handle like matrix quite easily. So it's like very useful in mathematical calculations, especially linear algebras. But pandas use it because it just store things. I think last week we talked about the internal. So pandas store all these table of data in blocks. So each block is actually a matrix in NumPy. So it's actually very fast because NumPy use a lot of formulas that's actually like down to very low level language. So I do believe it's a Fortran language that is written like Fortran library that is written in C. So yeah, so it kind of handle all these matrix very kind of very elegantly, I would say. But because pandas is something on top that give you more flexibilities and kind of try to be smarter, that can deal with a lot of more general cases of data, not just numerical data. So it's a little bit heavy on that side, but it's super powerful. So it's a super popular tool for data scientists and people who basically manipulate data. So today, so maybe I'll just have a recap, right? So last time we cover all these very basic things of pandas. We talk about how to of course install it, and then reading the data, writing the data to CSV. I also talk a little bit of Excel. It's actually okay to load an Excel spreadsheet into pandas data frame, but I won't recommend you to do it for all cases. It only do it if you need to do things programmatically, because Excel itself is not a very it's not like CSV. It's not flat, so sometimes you could come into troubles if you just blindly import it. So yeah, I would recommend you kind of understand your Excel spreadsheet before you really load it in. And also we talk about the internal of pandas. That's very interesting. You know how all these different actually objects within a data frame. So you kind of like dissect, having an anatomy of the data frame, kind of see what's inside. And we do a little bit of manipulation, head and tail slicing, and we change the data type of it as well. So yeah, so those are the very, very basic manipulation, I would say. So today we're going to talk more about the data frame methods, so those including, for example, getting some statistical, um, uh, statistical probability, no, statistical calculations of your data frame. And also, you can also use apply, which is a very powerful method that could let you do things, kind of iteratively. Also, we would do group by, and group by actually will give you some group per object that you could also use apply. So that's a very interesting thing, and I think it's slightly to the complex side that if it's a beginner of like to use pandas, then they would get a little bit confused. And also joining the data frames, there's also like some traps in there as well that I would like to talk about. So you don't have to struggle when you're really like doing those manipulations yourself. So what I gotta do is that I would so that's the slice. Even though you can grab the slice from my slice.com account, but there's not much here. Like most of the stuff will be in the Jupyter Notebook. That's I think we talked about that on the first tutorial, and it's still very, very bright because the Jupyter Notebook is also white at the background. So I kind of like I would tune down the light if I could. Yeah, I think it's the lowest I could go. So yeah, it's a bit too bright, but it's fine. Okay, I'll make it bigger as well. So you see that we have this is actually available online. So I forgot to put the link again. So last time I put it in post production, but actually I could show you where it sits. So if I go to GitHub, so actually if you're interested, you can go there to download it as well. So let's go to my repo. So me. So today's notebook is not uploaded. I'll upload it after I'm done with everything. So um, yeah, usually I would tidy it up afterwards and kind of so give some explanation for people who didn't watch the videos to kind of get it. So it's here, legend data. So it's my GitHub account is checking slash and legend data. So you can see here. So or if you put it in GitHub, you'll find it. So it's here and yeah. So this is so all this stuff are Creative Commons. So you can actually like use it in incorporate it in your tutorials, but I won't recommend you to put my code in your production code because sometimes for the sake of illustrating things, that it may not be the best practice for production. So but yeah, all these stuff are open and free, so you're welcome to use it. And so let's go to what we're gonna talk about today. So today we're going to talk about data frame method. So I've already prepared a link to the tutorials. Sorry, not to the tutorials, to the docs documentations. So I have read a Twitter a thread from Victor Steiner. So like he is a very senior guy in the Python, where he's been the Python coder for 11 years. He's also in the steering council. So basically he is very very high up in the hierarchy of Python open source community, and he tweeted that like he also sometimes he would also look at the Python documentation. So it because like Python is such a big thing, so like even somebody as as experienced as him would also need to refer to the documentation. So don't feel ashamed if you need to look at the documentation because yeah, because for example, like pandas is such a big thing, so I always refer to it, and because I would make silly mistakes easily. So we have covered a little bit of these things last time, the index and columns. I hope you remember that, and values. So also there are other things that you could get from the pandas. So I think I forgot to cover it. I gotta maybe talk about that today. So before we do anything, so we gotta read back our data, our CSV, which is the Pokemon one. So I think I have yeah, I was just being lazy as me. I was just like copy this that we have last time. So yeah, I just copy this. So yeah. Yeah, so you see that we have the Pokemon data. Oh, I haven't import. Silly me, silly me. Okay. Yeah, silly me, silly me. And also I want to print it out to have a look. So what I like doing is Pokemon df. Yeah, it's kind of like try to help me out but it's too slow. Okay, a dot head. Okay, so I can have a look at what's inside as well. Yeah. So here we are. We have this data frame that have some stats of the Pokemon's data. So we gotta play around with this. So another thing that we could do is that I forgot to show last time is to do the size. I think it's shape. Yeah, that's how I do. Nope. Uh, oh, it's yeah. So yeah, this shape is actually another attribute inside a data frame that gives you the shape of the data frame. So it tells you how many columns you have. So you have 12 columns here and 800 rows in your data frame. Okay. And that's something that I forgot to show last time. And you could also have other things. You could also have the memory usage. I don't know. There's actually a size there. It's not commonly used, but you can also do that. So, for example, what I gotta do now is to yeah. So maybe like I do a Pokemon DF dot size. Yeah, this would give me like how many elements there's in the data frame. So it would be like 800 multiplied by 12, so it gives you the number of cells. You can also like look at the memory size of it. So yeah, actually it's more interesting to know about that. So because sometimes you want to see if you can check whether you um yeah, whether you're running out of memory. You can do that as well. So you can check these as well. Yeah, and yeah, I don't know why it's printing out all these things because like yeah, I rarely use this one, but I think you have to maybe yeah, you have to put in the index and the deep. Yeah, so you can have a look. Like I don't use it that much because sometimes if you look at the size of your CSV is more or less the same size as your pandas data frame. So shape is the most common one that I use because usually like I would just know like okay, I can handle this CSV, I can load it in, I can do some manipulation, that's fine. Also what you could do is like you do a top at your terminal so you can see how many memories are actually being used right now, so how many left. That's what you can do as well. Okay, so what else that we have to talk about? So okay, let's talk about another thing that if you want to know more about your data frame, what you can do is to let me add another one down there. Okay, right. So what you can do is to do a describe. So yeah, so this one will give you a statistical kind of summary of your data frame. Okay, so for numerical data, it will just give you the mean and standard deviation. This would be more useful if you have numerical data. So also the quartiles. So it's like the lower quartile, the upper quartile, and this is the median, and yeah, and mean and max. All these basic statistical um, things that you can have. Also, the counts, I think it doesn't really like help a lot. But the thing is, like the downside of this is that it doesn't tell you anything about this this categorical data. So yeah, it's a bit limited, I would say. So what I think I gotta do is that if I want to know how many types here, right? So I want to know how many types of Pokemons is in the Pokemon world. So what I can do is that I could do a Pokemon DF, and I could pick out that column, which is type 1, let's say, and I can dot unique. And this one will give me all the unique type of the Pokemons here. That you can also count how many of them by doing just the length and see how many of them here. Okay, 18 different types. Okay, and also if you want to know like how common are these, I would recommend you do just like do some like porting to see like how these are distributed, how many class type are there, how many fire. But I think what you can also do is to do a count value. So let me check because this one is a bit confusing. So yeah, I do believe it's count values. Or I need to Google it because I can't remember. Okay, a value count, is it value counts? Yeah. You see, there's so many things I can't remember the name of it. Trust me, I do use it quite a lot, but I just like can't. and unique is actually a shortcut to give you how many unique things are there. So let me do it properly. Okay, you can do and unique here, and yeah. So instead of doing all these things, that's super. So the good thing is that this one you can see all the list, like the whole list of things, but you can also do and unique, and it already give you the number. So it's kind of like a shorter way of doing what I've just done before. Okay. So values, no, I think, yeah, no, it's value counts or something like that, or count values. I can't remember. Come on, let me do a search. Let me do a search. Okay, yeah, something like that. Is it? No. Okay, it's going to be a little bit difficult now, or maybe I just do a search on counts to see what I get. I know that I can have data frame counts, but it's only counting how many like non-NA cells are there, so it's not really counting how many uh, different type of values are there. So, yeah, I do believe I'm not dreaming things, right? I'm not like they didn't remove that function, right? So why I can't find it is strange. So yeah, maybe I just do a big Google to see if I can find it. And this is not in alphabetical order as well, so it's a bit difficult to see things. Okay, I'll just do a big Google, or maybe I can find it here. Value count. Oop. Hmm. Yeah, oh, you can do a goodbye. Oh, but I can also do a value counts. Oh, with the S. Okay. Yes. That's why I always look up the documentation because yeah, I always forget about these two things. So what you can do is that you can do a value counts on here. So value counts. Okay. So yeah, this one will give you like kind of this thing. You can actually put it in a histogram or like with all these different how many types. So you can see the most common type. It's also sorted for you, which is quite nice. The water types, there's 112 of them, and the least common one are the flying. So there's like 4 of them here. So yeah, and by the way, I think nobody do a pandas tutorial like me, like being so freestyle because yeah, there's so many things there, and people usually like put it be more organized. And in general, I think data scientists are more organized, so that's why I kind of switched my career into doing developer relations. But if you have any questions, ask now because I need to rehydrate, and or anything you want to know, like how to do this, how to do that, just put it in the chat. I love answering questions, so let me know, and I would just sip some water. Mm. Okay, so what else we want to talk about? So yeah, some of them we have looked at them before. Some of them are not very commonly used, so I don't want to cover them. And oh, you can find NA, so you can find then NA is actually no is it non-value? No, I know NaN means that is not a numerical value, but NA basically means that it's not available, or it's like the data is missing. So yeah, sometimes called NaN, not a number, or NaT, not a time. So but or like in some other languages, it may be null. Like in Python, if it's not exist, it could be none. But in the pandas data frame is NA. So you can actually check how many NAs are there. So you can be like do or you can drop NA, remove the NAs, and let me show you that thing. And yeah, so you can do a count to count the things that are not an NA, and then you can also drop NA, and you can check whether that things is an NA. So yeah, and I think there's drop NA. Yep. I think my data frame there isn't any NA there, so I can't really show you how that works. But you can basically just do a data frame dot drop NA, and then it will just like remove all the NA values for you. So you can also have the options to, for example, all your data. So if one of them is NA, you remove the whole column, like whole row of it, because if it's missing some very important data, then you just discard that record. So you can just remove the whole row, or you can remove the whole column. So the column needs to like be all exist. Otherwise I can't use it. You can also do that. So the axis would be the would be like how do you want to remove the missing record. Okay, so yeah, so also you can control if any of them is none, then remove it, or like you only remove it if all of them is none. For example, you have a column. That's more common, you know. You have the whole column, everything is NA, like basically nobody's filling in that column, so it's basically rubbish. So what you can do is like you can remove the whole column because all of them are NA. Sometimes you want to remove the row, like I said, like your data need to be all exist. If any of them is NA, you just remove the whole row. That could also be done. And um, yeah, you can also set up like how many like non-NA values. So you can be like, oh, don't discard that column unless unless more than 10% of them are NA. So you can tolerate that like 10% of the data are missing. You can kind of it's your model still can handle that. You can replace it with something else. It won't affect. But like if you got most of your column, like let's say 50% is NA, then maybe you don't want to use it in your machine learning algorithm because it's not really telling you much. And yeah, or you can so this is like the thing that I talked about last time. So sometimes some operation will change things in place. That's like changing your own object. Sometimes it will make a copy of it. So this one lets you choose. So the default is false. So it would it won't do the operation in place. Okay. So and yeah, and it will return the new one instead of but if you turn it on, so if you in place equals to true, then it will change it in place and it won't return anything. Okay. Um, yeah. So I don't know what else that is interesting because yeah, sometimes like because I've been using it, I've just like things they're natural, but I don't know whether that's something that is interesting for people to know or people want to know how to do that. So let me know in the chat and um, yeah, see anything. Oh, there's this rolling thing, and we can have a look of it, but I think this is a little bit more advanced as well. So you can create a rolling window of it, and then you can just sum that up. So you can have a cumulative sum of a rolling window, and um, yeah. So this is, but I don't plan to talk about that. But yeah, also after that you have to use dot sum in the chain because maybe you can do it. Well, why not? Let's try it out. So what I gotta do is that I don't want to take everything in my data frame to do it because I have mixed kind of type. I can have so let's do it and well it doesn't really make sense, right? Because but let's take attack and defense as our example here. So and yeah, I think I should always make a new one so I can keep them for the notebooks later. So I gotta decide I gotta create a new data frame that I have attack and defense in there. Okay, so these need to be string. Okay, okay, and right, and I can do a rolling, and I can window. I need to set a window of it, right? So window needs. Let's say I will have 3 of them, and then I think I would make it the sum. So let's see what happened here. Yeah, yeah. So basically, what it happened. So you can see the first two would be NA and because there's no more like because you need 3 of them to be adding, right? So it will like look it back 2 steps to look at the 3 of so it's like 1 2 3 of them. So now I can have a cumulative sum for this one. But yeah, but you can't yeah you can't have so 1 and 2 would be NA. So you would it depends on what you like. You can remove it if you want to. Um, so yeah, they're all accumulative sum. So, but it doesn't make many sense in our use case here. But it would make sense. For example, you're looking at some transaction data. You can see like how much accumulatively you got for that amount. For example, the money. Then you could add it up. And for these rolling windows, you can also have other like control over it as well. So like whether you want it to be centered. So if it's centered, then it would be like 2 would be like 1 2 3. Okay, so we can try that. We can center equals to force. So also you can set the minimum period and all this stuff. And I won't go to too much detail here, but let's try this out with true. So yeah, this one will be like 2 would be like 1, 2, and 3. So you can see this one now become like, the value for 2. Okay. And so that's that. And anything that's interesting, or if you see anything that's interesting, give me a shout in the chat. So otherwise, I would just move on to the next thing, because like we have like half an hour already almost, so we have to move on. Maybe yeah, maybe we'll just move on because we have too many things to talk about. Okay. So using apply. So again, I have a link to the very important documentation here that we're gonna use apply to do things, row by row. You can actually do it column by column as well, because you see you set the axis to be where there's column by column or row by row. So, and what I gotta do is that yeah, so I would just do some demonstration here because there isn't many things. So first of all, for apply, you need to have a function to apply to it. So what you can do is like you could apply a function that um, is self-defined, or you can write a lambda function to do that. So, oh, by the way, I think that I haven't covered lambda function in my in my Python tutorial somehow. So yeah, maybe I should do that one day. And yeah, so I assume that you know how to write lambda function, and so we could just maybe do that. So what I gotta do is that can I use, yeah, for example, attack and defense. I use this as an example again. So this is a new data frame. Yeah, I'm running out of ideas. Okay, so for now, and then we would we would do a new data frame dot apply, and then what I gotta do is that I gotta applied a function. Ah, yeah, lambda, and then x. Well, yeah, I know it's horrible naming, but I'll just like use x for now. So x would be the value of these two. So I would be like, I would see like if you have more attack and more defense, then you have very nice Pokemon. So maybe I want to know the sum of these two values, so I kind of know that which Pokemon is the most powerful. So what I gotta do is that, oh, I can't write another function like this, is it? Because I have two values. So okay, so maybe like I would do something more simple first. So maybe I would do, instead of this, I would just do attack. Okay, just do a very simple demo. So dot apply. So I would be so, and x times 10. Okay. Yeah, I kind of like out of panic, I kind of like forgot how to write a lambda function suddenly. I don't know why. Okay, so so yeah, I just multiplied them by 10. You don't have to, you don't have to write apply a lambda function, because you can just do, it's the same as let me show you this one times 10. It will actually do the same thing, but I'm just like for sake of demonstration, I'm doing it that way. So yeah, so you can see that basically what it do is just like it takes every single one of them, and just multiply it by 10. That's the thing. So let's do what I was trying to do like at the beginning. So if I want to add up the two, so what should I do? So let's do it like a more complex one this time. So what I gotta do is that I gotta write a function. So this one will be like power. Let's call it power. It'll be attack. Oh no, so I will take in a series. So this one will be a series. Okay. So oops, wrong button. Okay. So so now I will actually have series attack and defense. So dot attack plus yeah, I'll explain afterwards after my all my panic is over that this is capital. Yeah, this is capitalized. Yeah. Right. I think I'm spelling it wrong. That's correct. Yeah, I'm always. So this is actually a function, just like it'll give you a series, which actually it will be a series, because if you look at new df here, okay, dot head, So you see that we will have, so when you call applied, then it will also like, first of all, apply the default. It will come in like as column, so it will be column by column. So I don't want to do that. So this one doesn't matter because it's a series, so it doesn't have a column because it's just a series, so it will just go in one by one. But this one is a data frame, so it will, the default will be the axis equals 0, which is come in like column by column. That's something that I always forget. Like, so you have to set axis equal to 1, so it will come in row by row. So for each row, it will come in as a series of attack and defense like this. If you don't trust me, you can just look at it like this. So if you do a ilog, or yeah, .ilog. So I just want the first row. It will be 0, and then, so I hope you remember this one, the slicing. So yeah, so when you use apply, so this thing, we put in first, this, and then the second one would be this one, so it would be so on and so forth. So this one actually is a series. So series got two things. So it's got attack and got a defense. So you can do this by using the dot here and you add them up, right? Okay. So now let's apply it. So new df dot apply. So I'll apply the power function. So it's called power. And then remember axis equals to 1. So now, yeah, you'll see that I add them up. So if you look back here, like, can I print it out again, please? Yep. So let's just do a head. So I don't want it to be super long. Okay. Oops, spelling mistake. Yeah, so you can see like 49 plus 49 is 98. Yes. Yeah. So yeah. So you can see I just add them up together. Okay. This is how you use apply. So apply usually is like, it's useful, for example, if you want to do some, manipulation for like multiple inputs. So it's kind of like this. Otherwise, most of the time, if it's just one column, you don't have to do funky things like this. You can do something more simple. And yeah, so apply is like, my general advice would be don't use apply unless you have to, because apply is just doing things row by row, so it's relatively slower than if there's a pre-built function. So if you do time it, you see that this one is actually I think it will be like slower than this one because this one just used NumPy to handle this thing. So I think it'll be faster. So let's let's split this into two. So cell, I know. I forgot. I want to split it. Edit. Yeah, split cell. Yes. So let's do a time it here. So uh, time it. Yeah, and do a time it here as well, so we can compare. Okay. And yeah, I believe this one is much faster than this one because this one yeah, you can see that they're like, yeah, there's so much difference, like it's almost an order of magnitude difference. Yeah, so don't use apply unless you have to, because usually apply would be slower. And if you can think of another way of doing it using those built-in functions, they're faster because most of them use numpy the back. And as I said, numpy is kind of like, it's built on something low level. It's an optimized algorithm that has been built for decades ago that is still doing very well. So it's very pretty much optimized. And so yeah, so you can see this is so much faster than doing something like me. It's like stupid. So yeah, so but apply is still useful if you have cases that you can't find any built-in function that use numpy at the back to do it for you. Okay, so I think I'll just leave you with this, with apply, because we have so many things to talk about and I don't want to drag you for too long. It's Monday. I don't want to drain all your energy for the week already. So group by operations. So group by is another thing that is very interesting. I want to show you the documentation because it shows a very interesting concept there. So when you call a group by, so a lot of people would do a dot group by and then dot sum or dot group by dot count. So totally fine. That's very handy if you just want to group something. For example, I want to count. Let's say I want to add up all these Pokemons according to their type and see the sum of the attack of the type. So you can do a group by and then dot sum. So I'll show you in a bit. Actually, I'll show you now. So it's like it's easier to structure it that way. So what I gotta do is that I gotta take my Pokemon DF again. Okay, so I gotta do a group by the group. Oop. You know what? Yeah, I think this one would be the generation, right? Oh no, we gotta do the type, right? So yeah, let's do the type. Let's do the type 1. I know it doesn't make a lot of sense, so don't shout at me, Pokemon fans. I know that like all this stuff that I'm doing is a little bit stupid because like can't like it doesn't compare this way. I know I'm just demonstrating, okay? uh, right. So you can do a goodbye, and then what you usually would do, people would do with dot sum. So I hope I'm correct because I haven't done it for a while. So yeah. So yeah, you just group them by the type 1 type, and then you just do a sum of, for example, the HP, sum of the attack, So that's most people do group by, and it's totally fine. And it's handy because like it gives you a good summary of what happened here, right? And you can also actually count how many legendary are there as well. It's very handy. Yeah. So you can do a dot count, but it would just count how many in there. Is not that interesting. So but what actually happened under the hood is that once you call group by, it will give you a group per object. So what happened here is that this one will give you a group per object, and then after the group per object, you can apply a dot sum to the group per object, and it will give you this result. So let's say if we look at it like here, if you don't trust me, if you just run this, you see it will give you a group by object. Okay. So this object you can do something with it. It's an iterator according to the documentation. It's an iterator. So it's got an iter. So let's try if we can iterate it. So for I think it will give you back yeah, just item for now in. Okay. Yeah. So yeah, actually, actually, well, this group is the iterator. This group by object. So that one of the property of iterator is that you can put it in a for loop like this, and you can extract each of the items in it. So and I print it out, and you see that each one of them is actually a little data frame with that group in it. Okay, so that's very handy, and also it got a name or a key that is the is the type of this group. So this group actually got a name. It's the bug, right? So this one is used as a key as well. So so actually you can, what is this thing, right? So yeah, so it's a tuple actually. So it will become a key value pair actually. So you can have key and value. This is interesting, right? Of this, so you can type of key and type of value in it. So you can see that it will give you a string for the first one. So that's the key that I talk about. So that's the name of your group. And then the second one would be actually a data frame. So this is a group object. A group object is an iterator that if you iterate over it, it will give you a tuple. And for each tuple actually consists of name of that group and the data frame of that group. Okay. So that's super cool. And then, well, what you can do with group objects, like obviously you can call, like it got some built-in method in there, dot sum, dot count, I don't know what else, dot max mean, I think. Yeah, those aggregated functions that you could use to get those like quick result. But knowing this, right? What you can do is that actually you can do things group by group. So you can do things like, for example, I don't know if you want to print it out or each group you want to put it in a different CSV, you can do that. So what you need to do is just to, for example here, I can just put it into the different types. So I can do a value. Value is a data frame here, right? So maybe I should rename them, but yeah, we'll just call it key value for now. So value dot to CSV. Then I could put a name of it. So I can actually the file name I can also use an f string. So this one would be data slash. So I would put this in the group. Yeah. So what I gotta name it is call. So type, and I would put in the key Pokemons. Yeah, I want to do it underscore because yeah, Pokemon dot CSV. Okay, so I can totally do this. I can export them to different ones. So let's see if that works. And oh, doesn't. I think I did something stupid. Yeah, I don't have to. Okay, I'll just put in data for now. Yeah, or I can just create a directory for now. Yeah, because yeah, otherwise it's super messy here. So I want to create a new directory. So bear with me. New folder. I have to rename it. Rename. Call it group. Okay. Yeah. So now it should work. Now it should work. Okay. Yeah. So now if we go back here and we look at group, we have all these stuff, right? So this is super cool. This is super cool. Um, yeah, so you can group them and do them each of them one by one. So you have fully control of what you gotta do with your group by. So yeah, that's the thing that make it different of a SQL manipulation. SQL you can also use SQL to manipulate your data, right? So you can do it on your server side. You can do it like with your SQL query. But why do I do it in memory in using Pandas? Because you can have flexibility of doing things that you can't do it with your SQL database. Well, you can write a millions of queries to oh, give me that, select that, but you know sometimes you need to do things programmatically and you have to do it in Pandas. Okay. And yeah, also for that group object, you can also find the groups. So let me quickly demonstrate those to you. I would take this out again. I can do groups. So yeah, it will give me all these groups. So like I said, there will be a name. So this time is a dictionary. Okay, so you can have. So this one is truly a key value pair. So this is a key, and the value would be a yeah, would be all these indexes. So with these indexes, actually, you can extract it back from the original data frame if you want to. Um, so what else? And indexes as well. Yeah, those are the ones that actually you can get there. Get groups. Then yeah, get group is that it will give you back that CSV, like that data frame that I showed you before. So it's not something new. And so yeah, you can also do a group by the apply. So you can combine the two and do it there. You can do some transformation and aggregation. And aggregate that is that lets you do the sum and other things as well. It's not there. Okay, fine. So the aggregate is like let you do things like if you do a sum and a count. So you don't have to do dot sum and dot count and join them back together. You can do it that way, but that's a bit stupid. So you can just call it dot aggregate, and then you put in the function there that is sum and count. So it will give you both. Um, yeah. So yeah, and also you can call these computations that these are the the predefined functions that the mean, the sum that one I showed you before. You can have a cumulative sum, a lot of different things. Yeah, standard deviation. I showed you the sum before as well. Okay, so yeah, so that's the main thing I want to show you is to what is actually happen when you do a group by. So this is something that I when I discovered it, I was like, ooh, okay, I see. I can do this. So it's good to know because most people just do, use all these stuff. Use all this. This is common usage. Is totally fine. You're a brilliant, data scientist if you can do all this. But it's a step further if you understand what's happening within group by. Okay. So that's group by and joining the data frame. So that's also another very important manipulations that you have to do is to join the data frame. So I put some function here. Actually, it's like funny. when you join data frames, there's many ways of doing it. I'll show you later. So I think I gotta have a sip of water. I gotta rehydrate. By the way, this is from EuroPython 2 years ago. And yes, I gotta have a sip of water. If you have questions, put it in the chat and just let me know what else you don't understand, what else you want me to show a little bit more, especially with the group by object. So let me know. Hmm. Yeah, and I also put some infusion in it, so it's kind of give me a little bit of some taste of oranges, so which is great. I guess I can slice my own orange and dump it there, but I'm too lazy. Okay, so coin card. Um, well, coin card is I would say this is the most simple way of joining data frames. You just stick them together. So so it could be along an axis. So it could be like stick two together like this, or stick two together like this. Okay. Um, so yeah, it's relatively straightforward compared to the other stuff, and um, so I think I don't have two to show you because I don't have two data frames. I could, yeah, I think I could maybe manually make one, but I would show you the case afterwards when I do the merging and joining after. And yeah, so this way is just sticking them together. You also have a lot of options, which axes and which yeah. So this is like relatively simple. Oh, again, you can control whether it's making a new copy or not. So this one is making a new copy, okay, as default. So append is very similar. It just append, like your SQL thing. You just append it like at the bottom of it. So it's like this one here. That the series, instead of stacking them like this, you can just append it, one after another. So that's straightforward as well. So what I'm gonna do is I want to spend more time talking about join and merge. Okay, join and merge is so if you have used SQL before, you have some keys, right? Or if you've used Excel, then you have VLOOKUP. So actually mentioned here VLOOKUP. So you will have a key on both table, and you want to match them and join them that way. So the order of the tables could be shuffled, then you just join them by matching the keys. It could be the ID, so it's unique one by one match, or sometimes it's not one by one match. Then you have to decide whether it's a left or it's a right, it's outer or inner join. So uh, shall I explain that? I think if you have used SQL, then you understand a left join would be like it's unique to the left, right unique to the right to the other one. So the one that is calling is the left. Actually, the one that has been called is on the right. And so inner is the only one that matches would come in. Otherwise, it's flow away. Outer would be like try to match everything. If it's missing, just give me NAs instead. So yeah, so this kind of explained it very well. Um, okay, so let's do some actual things. So let's make up a data frame. So remember we have all these generations, right? So what I gotta do is that I gotta make an emoji representation of the generations. So I know that it's generation 1 to 6 in this data frame because I've been playing around with it a bit. So what I gotta do is that I gotta make a data frame that, first of all, before I make a data frame, I'll make a dictionary. So this one would be like generation dictionary. So what I gotta do is that I would have, and oops, what am I doing? Okay, so I will have generation 1, and I think I read it as a string or a yeah, that actually, yeah, so it's an object, so it's a string. So yeah, I should probably put this as a string, not a number. And what I gotta do, the value would be, I put a bunch of emoji in there. So if it's okay, if it's a I'll put a star there maybe. So if it's generation 1, I'll put 1 star, and if it's generation 2, I'll put 2 stars, so forth and so forth. Okay. This is a silly example, but yeah, but I gotta show you this. So I've been thinking like, how am I gonna show you? I only have one CSV. I gotta do something silly, and this is what I come up with. You can see that my brain is not very useful a lot of the time, just thinking about silly things. And yeah, but I think that's cool to like have the stars to represent the generations. I think it would be better if it's like rating, but we don't have rating for Pokemons because all Pokemons are cute. All Pokemon matters, and yeah, so we should not discriminate different type of Pokemons. They're all lovely Pokemons. So yeah, right. So I have this dictionary, and I'll make it into a data frame. So I will have a generation df. Oop. Ooh, come on, what's going on? Okay. Oh, it's going a bit silly right now. I think it's my emoji that is breaking it, so I'm not touching that cell. Generation df would be equals to pd.data frame. Oh, by the way, this is how you change a dictionary into a data frame, is to just put it in. So I'll just just print it out to see whether it goes well or not. Okay. So, oops, it doesn't. I think I need to put in the data. User scalar values you put on. Oh, so I have to declare an index, is it? Wait a second. Give me one sec. Yeah, pandas.data frame. Okay. Data equals to. Okay, I have to do data equals to. I think index optional. Yeah. I hope it's smart enough to use that as the index. So let's try. No, it's not. Okay. Yeah, maybe I have to use 1, 2, 3, 4 here. I don't know. Why is it not doing this? Oh, because it make it into a column, is it? Oh, okay. So let me think. Yeah. Okay, so I should maybe I should do from columns label to use as a column. Okay, let me think. So this is kind of surprising that it doesn't go the way that I wanted. I think what I gotta do is to make a data frame and then do a from. Haha. This is like when you spend a lot of time with pandas, then you know that like what's available for your disposal. Because yeah, from dictionary, then I have more control over how they read in the data this way. Yeah, I have orient, so column index. So I think it should be index data. Yeah, key pass index. Yeah, key should be as the row, so it should be index. So that's why. So orient equals to rows index. Okay. Oop. Nope. Ah. Okay. Ooh. Why is it doing something funny? Okay. I gave up. Okay. This is index. Okay. So yeah. Missing one. Oh, I forgot to put in the data. Sorry. Data should be our dictionary here, right? Okay. Yeah. This is what I wanted. I wanted to be 1, 2, 3, 4, 5, 6, and then with the stars, and it doesn't have a column name, but it's fine. Or maybe the column name should be rating. So maybe I could dot. How can I change it? Okay. This one is from dictionary, and then dot columns equals to not rating but generation. Gen. Let's call it Gen. Okay, because I don't want to have a duplicate name for the column. So and then print that out again to see if it changes the column names. Oh, it doesn't. Why? Mismatch. Several elements. If I have one elements. Ooh. Okay, maybe I could do it like here. Yeah, I could set it to columns equals to something. Okay. Columns equals to maybe like this. Yeah, I don't need this one. Okay. Oh, oh, because okay, I fall into a trap, so this one doesn't really update it, is it? Right. Okay. Yeah. So the problem is that like this one, if you look at the documentation, I'm not careful enough to see that if it's like from dictionary, then it will return a data frame, so you have to reassign them, so it doesn't change it in place. So Pandas are full of traps like this, so even I will fall into a trap. So if you see something that went wrong, don't panic. Sometimes just this silly little things, okay? So this one is the made up data frame that I did, just playing with emojis. Okay, I want to join this back to our Pokemon data frame. So this is what I gotta show you, but I like as a detour I show you how to make a data frame out of emojis, and so let's do the join. So Pokemon DF. So I can call join, okay, and then let's see what happened here. Right? Let's just put this one here. It won't work. It won't work this way because, well, what do you want to use as a key? Because, well, this one is just got 6 items. You got like many items here. Like the index doesn't match, nothing match, so it doesn't work this way. So we have to tell Pandas to use the generation in Pokemon DF as to match the key of this made up data frame. So let's go back to the not the apply, not this one. Let me close this one because this is not what I want. Okay, I think it's somewhere here. Nope. Yeah, the dot join. Okay, so so we have to set well, others we already put that in. This the made up DF that I made. So let's put the on there. Okay, so let's put the on to be oops. So on generation, so that's if I remember correctly, it's generations. Oh my god, this one is. I want to clear this output. Uh, where is the yeah? So it's generation here. So sorry about like I'm scrolling around. It's a bit dizzy for some people. I know. Sorry about that. And yeah, so now it works because you can see that it used generation as the key to look up. So this one got a little catches as well because it always so this one works because we have these 1 2 3 4 5 6 as our indexes. If it's not, then it won't work. If it's for example, I don't know what example I can make like for now because it took me quite a while to make this silly little example. But so for example, you have 2 data frames and then you just want to join them by um, I can't make up an example by the name. But the name is not the index. So um, so this one will actually you have to first make the name on the left. Not sorry, on the right. So the second data frame here. So this one, if 1 2 3 4 5 6 is not the index, then we have to make this the index first before we can join. Um, this is because when you're using join, it just assume that every time the index of these data frame that you put in here is going to be used, okay? This is a trap that I fall into quite often, and I was like, oh, how come it doesn't work? Because that's what happened. So one way you can do it is to make the column that you want to be joining the index first. So you have to set like the reset index, or there are different ways you can set the index of a data frame. So set index, I think I can't remember. Yeah, set index. So you can set something as an index for data frame here. Set a column as a data frame. As the index of your data frame, you can do that. Um, but I would give you another solution. The other solution is to not use join, but use merge. So let's try using merge. So merge work very similarly, but is on a different way. So my advice would be if you're matching just the index of both data frame, use join. If you're matching, for this one that is calling the join function, if it's not an index, it's still fine. You can still use join. But if the second data frame that you are calling doesn't have that key as the index, then maybe consider using merge. Um, so merge is very similar to join, and let me go back here. Yeah. So yeah, you can see how the documentation is being so useful here. Okay. So merge lets you again, you can have it's very similar. So I just copy this one because this is super similar. So instead of join, we use merge. So you put in a data frame as your right hand side. But this time, instead of just on the Pokemon DF, I use generation as a key. I could have control of both. So you can have a left on and a right on. Okay. So this on is not very helpful because it's just make it more powerful that you could use column or index to join. So you can join column as well. It's like this, but yeah, it's not that common to join on a column anyway. So yeah, so left on and right on. So you can have control of what to use to join on the left and what to use to join on the right. You can also say, oh, both of them use index. So basically, merge is a powerful version of join. It gives you all the flexibility of like how you want to join it. It's like, it's different way you can join it. You can join on the column. You can join on the index. You can join like the left, whatever you want to use, the right, whatever you want to use, which whatever column you want to use, left and right, whatever index you want to use. It just gives you full flexibility of doing that. So I'll just show you left on and right on here. So I would, left would be um, on generation, and the right would be just right index. So right index equals to true. So I would use index for the right hand side. So yeah, it does the same thing, but it's more it's how can I say, it's more powerful using merge. So show should we always stay with merge? Yeah, you can, but I think some people are more comfortable with join because it kind of work more similar to VLOOKUP and the SQL syntax. So some people are more comfortable on that, but merge kind of give you a more powerful version of that. So I can recommend one over each other because I think they're both. I use both of them. Like just I don't really care. Whatever that works for me, works for me. So I would say that if one of them is on the index, then just use join. Then you got less things to put in. But if you want a full control, use merge. So yeah. So I think that's it. That's an hour. It's perfect. So ask me any questions, anything else you want me to talk about with pandas. I think that's more or less I want to cover for pandas. Of course, there are more to learn. Or always, your documentation is your best friend. If you want to learn more about the internal of pandas, if you want to have your code, your contribution inside pandas, join a sprint on pandas. Uh, I think in the past there are quite a lot of documentation sprint on pandas. Some of them are mentored. That means that we kind of have more senior people there to help newcomers to start working on pandas. Because pandas is so big, so like any big library contributing to pandas, it could be very scary if you do it on by yourself at home. So we try to organize sprints to help people to get started. And so if there's a new one, I would put it in my Twitter, let you know. Otherwise, we have closed this chapter of pandas, and next time we gotta talk about something else. And I'm still thinking what else that I want to talk about. So let me know if you have anything like scikit-learn, NumPy. What else? We have Matplotlib. Any topics that I talk about, on my first tutorial, like anything related to data science that is pandas, that is Python, that I am happy to talk about. So yeah, let me know what you want to learn, and otherwise I'll just randomly, blindly pick a topic and go with that, or anything that I feel like I want to talk about, or anything that I feel interested to talk about. So yeah, so other than that, I think I would just see you next time and sign off right now. So yeah, thank you for joining. See ya.